Okay, good morning, good afternoon, good evening, whatever time you're in right now. This is Mr. Jodry, and welcome to your first flip. This is where you take the notes at home, and then we do all the work in class. Today, what we're going to talk about the law of sines, and you're going to notice, if you haven't seen by my picture here, that we're not working with right triangles today. So today is one method of finding sides and angles for not right or oblique triangles. So that's the big idea. Before we get going, let's just write down what the law of sines is. So the law of sines has its own formula. All it is, pretty easy to follow. What the law of sines says is sine of an angle over its side, that ratio is the same as another sine of the angle over the angle itself. So angle A, angle B, angle C, whichever angle you're working with, it's the same idea. And when to use it, just once again. Now technically you can use this for any triangle you want, but we usually just save it for not right triangles or oblique triangles. Okay, let's talk about this first example here that we have. Obviously this is not a right triangle. If you wanted to figure out this other angle measure right up here, just 180 minus 80 minus 40, and that'd give you, what, 60 degrees. So obviously this is not a right triangle, so we can't use SOHCAHTOA, we can't use Pythagorean theorem, we can't use a special right triangle here. So we have to use another method. Okay, so the big thing to look for first, you have an angle, you have a side across from it, you have another angle and another side across from it. So we can use law of sines here. So law of sines just says if you take the ratio sine 80 degrees over its side across from it, so x, that ratio would be the same ratio as if you took sine 40 degrees over the 12 over the side across from it. Okay, just like what we've talked about before in class, solving a proportion, cross multiply, so one diagonal equals the other when you multiply them. Okay, 12 times sine 80 degrees, so just multiplying together, equals x times sine 40 degrees. Now, you could write sine 40 times x, x times sine 40 degrees, but don't forget the rookie mistake you might make if you write it like that. Okay, the last step here, and notice I'm not punching anything in the calculator yet, or I could say the calculator, is we're not punching anything in yet. So keep it till the end. The last step, don't forget, all you're doing is getting x by itself, nothing fancy. Just get x by itself, so divide by sine 40 degrees, and you end up with x by itself on one side, and then you have 12 times sine 80 degrees over sine 40 degrees. And if you punch this in your calculator, you should get around, if you're going to two decimals, so approximately 18.39 if it's feet, yards, meters, whatever side length unit you're going for. Okay, so here's another example. Um, you don't know if this is a right triangle, so you can't jump straight to SOHCAHTOA, special right triangles, or Pythagorean theorem. So we're going to have to use law of sines. That's the only thing we know how to use right now. And in this case, we're finding an angle measure. And just to make sure, before you use law of sines, make sure you have an angle and a side across from it. And same idea, you have an angle and a side across from it. So good, we can use law of sines. So set up for the law of sines on this one, just like the last example we did, sine of the angle over its side across from it. So sine x over 14 equals sine 63 degrees over 12.5. So you cross multiply just like the last example, and you get 12.5 times sine x equals 14 times sine 63 degrees. Now, unlike the last example, well, just like this last example we did, you want x by itself, but in this case, you not only want x by itself, remember, it's technically trapped inside parentheses. You're taking sine of x. So you need to get sine x by itself, not just x. So in this case, you're going to divide, but you're dividing by 12 and a half, not 12 and a half and then sine of something that you don't know. Okay, so after you divide all this, we're still not going to punch anything in the calculator yet. You get sine, not just x, sine x equals 14 sine 63 degrees all over 12 and a half. And then to get the x by itself, don't forget inverse sine. So x would equal inverse sine of all this, so 14 sine 63 degrees over 12.5. Now, if you wanted to punch this in first and then take an inverse sine, that's fine. But either way, you should get, when you punch this in, around 86.31 degrees. Don't forget this is an angle measure. So about 86.31 degrees. Okay, for this last example, we're going to solve this triangle just like we did last week with right triangles. Remember, solving a triangle just means get all the sides and all the angles. Well, in this case, well, it's not a right triangle, so we can't use any of those right triangle methods, so we have to use law of sines. It's the only thing we know so far. So getting the other angle is really easy. All three angles have to add up to 180 degrees. So 180 minus 100 minus 53 should give us 27 degrees. Okay, so there's the angle. Now the next step is we need to get the other two sides. So we're still going to have to use law of sines in this case. So we have an angle and a side across from each other. Okay, good. Now in this case, since we have this angle, the 53 degrees and the 9, it doesn't matter what other side we get in this case, because we have the angle across from either of the other two sides. So let's just get side A first, why not? We'll go for side A first, and then we'll get side B. Okay, to get side A, we have to use law of sines, because remember, this isn't a right triangle. So sine 27 degrees over A is the same ratio as if we do sine 53 degrees over 9. Okay, you kids know how to solve this by now. Cross multiply, divide, and you get A is around 5.12, whatever unit this is. Okay, and then to get side C over here, to get side C, we still can't use a right triangle method. We're going to have to use law of sines. So same idea, and don't forget, use what you're given. So use the 53 degrees, use the 9. Don't go off a side you've already used if possible, so you don't make a mistake twice. Okay, so to get side C, we're going to use this sine 100 degrees. That's across from the side we want. And then equals, we're going to use this 53 degree angle again. So sine 53 degrees over 9. You guys know how to solve this. So cross multiply divide. You get C is approximately 11.1, whatever unit this is. So here's your two sides, triangle solved, and that's the law of sines. Okay.